Welcome to the Explainer. Today, we're talking about the secret blueprints that make AI agents work, not just in a demo, but in the real world. We're getting into agentic design patterns.
All right, let's just get right into it, because this is a problem I'm sure so many of you have felt. You get your hands on a super powerful language model, you build an agent, and it's amazing for a minute. Then you put it out in the real world, and it's unpredictable, unreliable, and it just breaks in ways that make no sense. It's a really common and frustrating story. So here's the thing. The secret to making these agents work isn't just getting a bigger model. It's all about the blueprint. The most reliable, powerful agents are built with a really clear structure that dictates how they think, how they act, and most importantly, how they fix their own mistakes. These design patterns are what separate a cool prototype from something that actually works. So we're going to start with the patterns that shape an agent's internal thought process. This is all about how it analyzes a problem, catches its own errors, and actually makes a plan before it just rushes in and does something. First up is one you've probably heard of, REACT. It stands for Reason and Act. And it's pretty simple, really. Instead of just spitting out an answer, the agent is forced into a loop. First, it reasons about what to do. Then it takes one small action. And then it observes the result. It's like forcing the AI to show its work, step by step, which is an absolute lifesaver for debugging or for any kind of complex research task. And this slide really highlights the classic trade-off, right? On one hand, you get incredible transparency. When something goes wrong, you can look at the log and see exactly where the logic went off the rails. But the price for that clarity is more time and more money for every single one of those loops. Still, it's pretty much the go-to starting point for any task that isn't totally straightforward. Okay. Next, we have the reflection pattern. Now, this one is like giving your agent its own internal quality control department. The agent will generate a first draft of an answer, but then it stops. It literally switches roles into a critic mode and reviews its own work, checking for flaws or logical gaps before it gives you the final answer. And this is where that pattern really pays off. For anything where a mistake is expensive, think about generating code, writing a factual article, or doing financial analysis, this is invaluable. That little bit of extra processing time is a tiny price to pay to avoid a really critical error down the line. Think of the planning pattern as the agent that, measures twice and cuts once. Before it does anything, it looks at the entire request and breaks it down into a super detailed step-by-step plan. It maps out the whole journey. Only after that entire roadmap is built does it actually start step one. This is your go-to for those really hairy projects, maybe a complex data migration, where doing things out of order would be a disaster. It prevents you from wasting time and money on a bad start. But, for a simple request, creating a whole detailed plan is it's overkill. Okay, so we've covered how an agent can think. Now let's switch gears and look at the patterns that define how an agent acts. This is all about how it connects to the real world, using tools, working with other AIs, and, of course, working with us. Tool use is, honestly, probably the most important pattern for making an agent actually useful. It's what lets an agent break out of its static knowledge and do things in the real world, right now. It can call an API, search a database, or run a piece of code. This is what turns it from a chatbot into something that can actually get stuff done. But, and this is a big but, there's a catch. Your agent is now only as reliable as the tools it's using. If that API it depends on goes down, your agent goes down with it. So the real challenge here isn't if you should use tools, you almost have to, but how you're going to manage their failures and all the complexity they add. So instead of trying to build one single genius agent that knows how to do everything, this pattern creates a whole team of specialists. You have a manager agent that acts like a coordinator, and it routes tasks to the right specialist. For instance, a research agent might pass its findings to an analysis agent, who then sends its summary to a report writing agent. A quick word of warning here, you should only use this pattern when a single agent really can't handle the job. Because while a team of AIs can tackle some incredibly complex problems, the difficulty of building, debugging, and paying for it all goes up a lot. Don't reach for this one unless you absolutely have to. Now for something a bit simpler. For tasks that are predictable and you do them over and over again, the sequential pattern is like a factory assembly line. It's a fixed pipeline. Agent A does its job, and it always passes its work to Agent B. Agent B does its thing and passes it to Agent C. The path is set in stone.
This is perfect for structured workflows, like processing a document where you always extract text, then analyze it, then summarize it. It's predictable, it's fast, it's cheap. But the downside is obvious. It has zero flexibility. If you need to adapt to a new situation, this pattern just can't handle it.
And finally, we have a really important one, the human-in-the-loop pattern. This one provides some crucial safety rails. It basically admits that some decisions are too important to be fully automated. So the agent does all the heavy lifting, but it's programmed to pause at critical moments and ask a human for the final say-so.
This is non-negotiable for anything high stakes. We're talking finance, legal work, or moderating sensitive content, anywhere a bad automated decision could have serious consequences. It's the best of both worlds, really. You get the speed of AI, combined with the judgment and accountability of a real person.
Okay, wow, that was a lot. 7 different patterns. And you might be sitting there thinking, where on earth do I even start with all of this? It can definitely feel a little overwhelming.
But don't worry, choosing your starting point can actually be pretty simple. So let's just walk through a really practical decision framework right now that'll help you pick the right blueprint without over-engineering your whole system from day one.
All you have to do is ask yourself 3 questions. First, is the workflow predictable? If the answer is yes, just start with a sequential pattern. It's cheap and fast. Second, is getting it right more important than getting it fast? If yes, then you need to add either reflection or a human in the loop. And third, is this task genuinely, truly complex? Only then should you start thinking about the heavy hitters like multi-agent or planning.
And if you take one thing away from this whole explainer, let it be this. Avoid the temptation to go big from the start. The most expensive mistake you can make is jumping to a complex pattern too early. Honestly, most jobs can be done really well by a single agent using just those first 2 patterns we talked about, React and tool use. Start there. Keep it simple. And remember, your first choice is not your final choice. The best systems are never built in one go. They evolve. You launch with one pattern, you see how it does in the real world, you find its breaking points, and then you adapt. You iterate. So go ahead and choose your starting pattern, but remember to invest just as much in your ability to watch, to learn, and to iterate on it. That's how a good blueprint turns into a great system. So the only question left is, what problem are you going to solve first?